All right, guys. So in the last couple of videos, you learned about the fact that as current runs through a wire, that it creates a magnetic field going around it, right? And as that wire goes in a loop, it can create a magnetic field going through the loop one way and then on around the outside of the loop in the other direction. Now, what that means is that if you have a charge, a positive or negative charge, any charge that's moving along, that charge will create a magnetic field. So here's the next thing we're going to add in, and the last thing really for this part of this unit is, what if that charge that is creating a magnetic field now passes into a magnetic field that's created by something else, right? Like I have a north and a south magnet that are going across, and it passes in the middle of those. So it passes through a magnetic field. What's going to happen to it? Well, the magnetic field that particle is creating is going to interact with the magnetic field that it's passing through, and the particle is going to feel a magnetic force. Hopefully that kind of makes sense. The fact that the particle is creating its own magnetic field as it moves, and if it's going through another magnetic field, those two magnetic fields are going to interact. They're going to do something, right? So that's what we're going to look at right now. Now, we're not going to do any math with this unless you choose to. There is an optional part that you can watch after this if you want that will go through some of the mathematics of that, all right? But for everybody, all I want you to be able to do is determine the direction of the force, all right? So let's go ahead and draw one up here. Let's consider our first situation here. Let's consider that we have a positive charge that's moving to the right, and we're going to have it pass into a magnetic field that is going into the page. And remember that X's represent into the page. Now I'm going to introduce to you a third right-hand rule. Okay, now just like the other two, the right-hand rule works for a positive charge. If you decide that you want to work with a negative charge, then you can either use your left hand, and it should give you the same thing, or you can use your positive hand, and whatever the result is, you can just do the opposite. All right, and I'll show you that for a negative in just a minute. All right, now this is how your last right-hand rule works. You're actually going to need your whole hand and your thumb this time. Okay, so your finger, your pointer finger, is going to represent the moving particle, right? You're pointing in the direction that it's moving. So right now, I have that the particle is moving to the right. All right, so for me, the right is over this direction. So I'm showing that the particle is going this direction to the right. All right, you make sure that you're going to your right. All right, so I'm going to the right. Now, my other fingers here, not the thumb, but the other three fingers are going to point. I'm going to bend them so that they can point in the direction of the magnetic field. Okay, so velocity, magnetic field. Now I can rotate my hand if I need to, right? But right now I see the velocity is going to the right, and the magnetic field is going into the page, which that's going to look like it's going towards you. All right, now you'll notice that if I do that, my thumb is pointing up. That's the direction of the force on the charge. Your thumb kind of pushes it over in the direction. And so in this situation, we would say, well, the velocity is to the right, magnetic field is into the page, and the force, the magnetic force, so we'd go Fm, is up. Now again, we're not putting numbers with it, we're not calculating, we're just talking about the direction of the force. Okay, let's look at it slightly different. What if we didn't have a positive charge? What if it was a negative charge? All right, so let's go ahead and put in a negative charge here. What would happen? All right, well, you could use your right-hand rule and say it's going to the right, magnetic field into the page, force up. Oh, but that's for a positive, so therefore the negative would have a force down. Or you can use your left-hand rule, because your left-hand rule is for a negative. Again, your pointer finger is going to represent the direction, the velocity. Your other fingers need to represent the direction of the field, which is into the page. So I'm going to go into the page here. And then you'll notice that my thumb, if I do that, velocity this way, fingers into the page, the force is down, which is exactly what we came up with right there. All right, let's look at another set. Let's see if we can consider a different option. Let's go positive charge, and we're going to have that positive charge moving to the left this time. And let's say that the magnetic field is down. All right, just like that. So what would the force be? Right hand rule. Finger represents the velocity of the particle, which is to my left, so I'm going to the left. Make sure you're going to your left. The magnetic field is these fingers. Now I'm going to have to turn my hand so those fingers are pointing down, and then look at which direction the thumb is pointing. The thumb is pointing towards me, which is out of the page. And so we would say that the force magnetic is out of the page. All right. What if we did the same thing for a negative charge? So instead, let's change it to a negative charge here. Okay, now again, you could use your right hand rule and just say, well, it's going to be the opposite. So you could say, what's the opposite of out of the page? It's into the page. So we could say, all right, I already know it's going to go into the page. But just for argument's sake, let's use our left hand rule. Okay, it's going to the left, right? So I need my finger pointing to the left. The magnetic field is down, so these fingers right here, they need to point down like this. And notice that now my thumb is pointing right into the page. And so for a negative charge, the force would be into the page. All right. How about this? How about this? Let's look at a different situation. Let's say that I've got a magnetic field going into the page. All right, and I know that the force is to the right. Can I figure out, this is a positive particle, you can see it drawn on there. Can you figure out what direction the particle was moving? How about that? Okay, so the moving should be the pointer finger, so I don't know what direction that is, but I do know that my fingers, the magnetic field, should be pointing into the page, right? So I need to make sure my fingers are going into the page. Now, my finger could still point any direction, right? That's still with my fingers pointing into the page. So now, what I'm going to do is I want the force to be to the right. So the right is over that way, and yes, I do kind of have to turn my fingers really weird, or maybe, oh, I guess that's maybe a little bit easier. Okay, so you're going to have to twist your hand around. So I got the magnetic field going into the page, I got the force going over to the right, and what direction is my finger pointing? It's pointing down. My second grader's here, she just got it. Okay, so that means that the velocity must have been down. All right? Pretty cool, huh? All right, let's check this one out now. Let's check this one out. What if I have a negative particle moving up at an angle to the magnetic field, right? All of the other ones were perpendicular, which made it a little bit easier. But what if it's moving up at an angle? No problem. No problem. We're still going to take, you can use right hand or left hand, but because it's a negative particle, I'm going to use my left hand here. Okay, so I'm not showing the video anymore. You got to try to follow along with me. Okay, the finger is going to point up and to the right, because that's the velocity of the particle. Now, your other three, you've got to turn. You got to keep your finger pointing up and to the right, but the other fingers are going to turn until they are able to point in the direction of the magnetic field. Now, it's not going to be a 90-degree angle anymore. Make sure that your finger is still pointing up and to the right, and that your three fingers are pointing over to the left. And you should see now that your thumb is pointing which direction, Lily?
down?
Down into the page, right? Not down on the page, but that's right, directly towards the page. And so what that means is that our force is, the magnetic force is into the, not the page. Just like that. All right?
Yeah.
Magnetic force into the page. My daughter's making fun of me that I don't know how to spell the right. I know how to draw the, spell the. All right. Last one. Let's look at one more. I'm gonna get. Oh, I can't get rid of that. So we're gonna get rid of the one we just did. Okay, it's done. And we're gonna do one more. All right. What about this? We'll go back to a positive charge. We got a positive charge moving to the right, and we got a magnetic field which is directly to the left. All right, let's see if we can use our right hand rule. Yep, make sure you get your right hand. Don't get your wrong right hand. Okay, right hand, finger needs to point in the direction of the velocity, so that's over to the right. Now your other three are going to point back in the direction of the magnetic field. So they're going to be pointing exactly the opposite direction of your finger. Now a lot of you are probably saying, oh, the force is up. Wait. If you turn your hand, rotate it, look, your finger is still pointing in the direction of the velocity, and your magnetic field fingers are still pointing back in the opposite direction, but now your thumb's pointing in a completely different direction. In fact, you can turn your hand 360 degrees around. Well, hopefully you can't turn your hand 360 degrees around. That would either be painful or something's wrong with your joints. But if you could go around the other direction, I guess. Yeah, don't stop. You're going to hurt yourself, Lily. All right, if you can turn it around, you can notice that I can keep my finger pointing in the right direction and the three magnetic field fingers pointing back in the correct direction, and yet the thumb can be any direction at all. That is a problem. Now, what that means, how we're going to interpret that is we're going to say that there is no magnetic force. Okay, it doesn't happen. There won't be a magnetic force if the motion of the particle is parallel. So if V is parallel to the magnetic field, very often they'll use a B. I don't know why B, don't ask me. I'm on a video anyway, I wouldn't be able to answer you. So if the velocity is parallel to the direction of the magnetic field, then you will get no magnetic force. All right, but only if it's parallel. All right? Okay, that's it for this video. Hopefully that is enough to get you started. You can practice it a little bit on the worksheet that I got for you. We'll see you later.